let us wait for the recording to kickstart. All right. So very good morning to our speaker today, Dr. Keeratpal Singh, and also to all the students. Today we are very honored to have our adjunct prof with us, Dr. Keeratpal, on to talk about a topic on big data analytics, AI, and also IoT. Yeah? So AI stands for artificial intelligence. IoT is Internet of Things, industrial use cases. All right. So a quick background, a brief introduction to Dr. Keeratpal. He is actually our newly appointed adjunct prof. Okay, and as you can see from here, this is just a very brief biography of our speaker today. He has an extensive CV. I think Dr. Keeratpal received his doctorate degree in electrical and electronic and system engineering from UKM back in 2009. And he has a master's degree in electrical and computer engineering from University of Tennessee, US, a Bachelor of Science in Electrical Engineering with a major in electronics from Michigan Technological University. That was in 1992, 21 years ago. All right. So he's currently the Chief Data Scientist at Axiata, and also at the same time holding the position as a Principal Architect and a big data analytic consultant at Axiata Digital Labs. So Axiata Digital Labs, I believe, is one of the arms of Axiata Group for digital services. Okay, so if you are not familiar or unaware about what is Axiata, it's a very big regional multinational company. So the two more familiar household brand names are Celcom and Boost. I think you know Celcom and also Boost application. So these actually are under Axiata Group. Of course, Axiata is a regional player, so it also owns multiple telcos across Asia, such as in Nepal, I think India, some other countries. Okay. Prior to his role at Axiata, Dr. Keeratpal also provided his expertise at Mimos, holding a position as a principal data scientist. And also he was a VP, a Vice President for Research and Development at 24 Mobile Advertising Solution. It's a Swedish company. A CTO at Salient Synergy, which is somewhat related to a Norway company. Regional Manager at Celcom. Research Consultant at Philips at US back in 2000. All right. He has over 25 years of experience in developing analytic solution across various areas using big data, data analytics, digital services, telco, and mobile advertising. Okay, so without further ado, I will pass the floor to Dr. Keeratpal. Doctor, can you share the screen? Let's try it out.
Yeah, sure. Hi, good morning, everyone. Let me.
Yeah, unshare first. Okay.
Yep, so. Can you see my screen? I guess.
Yes.
All
Yeah.
right. Okay. So let me start with the topic right away, since we have about an hour 15 minutes for this talk. I guess you can see my video also. I will turn off the video because I want to make sure that all of you are able to see the slides clearly from the remote location I'm talking from. So basically today I will talk on big data analytics, AI, and also the IoT industrial use cases, because I know you have a project also due at this particular nearing this time frame. So I will talk about another use case for elderly purposes. So let me just jump in straight to what are the topics that I will be covering. So first of all, I'll be covering AI, which is artificial intelligence. Since Uniten and Tenaga are working very closely together in R&D and many other ways. So I think it's only fair enough for me to share on a use case for AI, which is in a renewable energy setup. I will show you a video, so we'll get that started as a warm up for all of you this morning. So then I will talk about how do we identify target group persona, which means what are the type of targets that you would want this analytics or AI to be represented by specific groups. So for example, you can have businessmen, you can have students, you can have elderly. So since we'll be talking about elderly care related later on from this presentation, so it's good that I will just mention you how you identify persona. And then I'll also talk about the usage of descriptive analytics, what is machine learning, and what are the approach to solve the pain points. Means pain points mean what is your customer's biggest headache or challenges. So then I will also touch upon understanding the web part analysis, because sometimes some of you might be working on a web type of analytics, so you probably would want to know what is it all about. And then some of you might have already worked on social media type of analysis. And then I'll also share that companies like telecommunication companies and many other companies also work on location based analytics, the movement of location or the movement of your sites. Could be your station, substation, could be a power station, could be a telco station, or it could be anything else that's available on a map that you would want to also monitor and see, and also people movement sometimes. And then I'll share on how to innovate strategy if you plan to also do market type of analysis. And then how do you provide automation in near real time? Real time means like immediately, whatever you have right now, you're getting it on the spot. So it's like live, you're looking at it. Near real time could mean it's a bit slower, maybe within a few seconds to a minute and so, or maybe like a couple of minutes. So that's still okay. But there are some cases where you don't get it on near real time because the data comes in slow, and you may get that in hours later or a day later. So that's not near real time. I will also share about example of artificial intelligence use cases, and I will share on advanced analytics, because sometimes you may just hear about analytics. I'll tell you a bit more on advanced analytics and how it's being used in businesses, and especially you may have heard about companies saying that, hey, they're transforming to digital businesses. So what is digital businesses compared to the traditional businesses, which uses more of you know paper, and then how they are moving it, everything on a computerized type of environment. Then we will cover a bit on developing real-time insights and decision making. CapEx mean capital and expenditure investments, because sometimes you would want to know how it affect your return of investments. If there is a problem, you would be able to actually know the problem real fast, rather than you knowing after a month later. So also analytics and AI are able to identify potential risk. So that means that anything happening, you can have your software or your system notify you immediately, so that you don't wait until somebody complains. Sometimes we have electricity problem at home, and then we will call Tenaga and say we have electricity problem, but before that happens, there would be automated notification channels that will inform the operation and maintenance team to come and even rectify the problem before somebody calls, or when they call, they are already aware what's happening. So then finally, I will cover a holistic view of an elderly care IoT type of use cases, which I have taken from some references. I'll share with you those references, and I will tell you what are the things to add and what are the things to consider, and how do you actually look into best practices for all of these areas. So let's look into a video. Basically, AI in renewable energy. I think this will be something interesting. It's a very, very short video, about 3 minutes. So if you can pay your attention, it will be great to cover up our warm-up session this morning.
But Akira, I think the voice from the computer is not transmitting out.
Oh, the
We can't
voice.
hear the description. But the student can go back and have a look at the YouTube because the link is provided.
So you guys can actually take a look at it later. So maybe I'll just give you a brief point here. Okay, probably you just can have a look of the graphics. It's just a quite a fast view. So it talks about integrated microgrids. Earlier, it talks about the control center, how it's being set. So these are a few companies that are already deploying it, the renewable energy using AI. Anyway, since you have the video, I will move on. Okay, so those were just a brief, warm up earlier that we talked about on the YouTube video. But now let's go into the detail of it. So how do we identify our target audience persona? Which is, for example, this case is a business travel. So, for example, a lot of marketing company they would want to say, okay, I want to do a campaign, but who am I targeting? Because you don't target everybody, then it's a waste of effort and also waste of your advertising revenue. So in this particular case, you need to know the motivation of the business traveler. For example, this particular group, they travels frequently, or they often purchases gift cards like food. What are their goals? So again, you need to also look at their behavior, whether they are web savvy. If they are not web savvy, then when you target your marketing channel advertisement, how do you do that? So this is all important. And then sometimes you need to know the group that you are targeting, what is their roughly age group, and then you can collect a few type of surveys from the type of groups that you would want to include. So you could have it in a different location. Like for example, this person is age 46. The occupation is account director from US. Um, so another target group is, for example, students. So again, here you need to know what are their motivation. So for example, this particular student care about social responsibility, and also appreciate artisanal quality, and then likes to try new food and beverages. So consider a part-time job to help with expenses. So you need to know a bit about who you are targeting, because like I said, it's only effective if you know the groups that you will be targeting. So this is good in terms of marketing, but in terms of engineers, we need to know, like for example, when you build buildings and you build certain type of facility, you need to know very well about your audience. What are their group, their target group, what are their likes, their dislikes, what you can provide them, what you shouldn't provide them. So these are all very, very important. And then, for example, this type of persona has their own goals. They like to shop at socially responsible businesses, spend time with friends, and of course, they like to not spend a lot of money in certain places. So therefore, you won't advertise something very, very expensive and to them. So again, you need to know the purpose. So here there are three basically groups of areas that you need to cover: motivation, goals, behaviors. And this is a group for students. So again, you can do a group for elderly, you can also do a group for business people, you can also do a group for retirees, you can do a group, many other type of group. And then of course you need to target more than just group. So let's say if you look at advertisement that you would want to sell something, you need to know, again, the persona, the group, segment of which group of customers you want to target. You also need to know what are the state. Like, for example, State here, I don't mean the state in the country, but state of what the customer's current personalized need in order to improve their user experience. Sometimes it could mean that what are they doing at that particular time? Could they be walking, reading an email, or could they be watching TV at home at that certain particular time? What type of state they are in? So journey is also, of course, with this group of customer, what do you want to interact with in your business. So you need to, let's say, for example, if you are providing a florist shop that sells flowers, so you would want to know that first you would want the customer to look at probably something online and then select the type of flowers, and after that go and pay those. So something like, the journey for them to go and buy, and then after that pay, and then find a way for the items to be delivered. And then channels can mean many, many ways that you want to target. Channels can mean you want to channel it through Facebook, you want to do it through web, you want to do it at the shop, the physical location, at the store, either through SMS, or either through many, many other channels like newspaper, magazines. Content would mean what do you want to be shown to this particular group? Is it SMS content? Is it graphics on a website? Or is it just a poster, or it's something on the wall? So it's all up to how you want to effectively target. So this is all about targeting, and of course, many companies, they do experiments. Sometimes certain things work, sometimes certain things don't work, and then they try it at different location. So I won't go too detail here because I want to actually capture your imagination and innovation today, to know that these are very, very important when you design your project or whatever work that you actually look into. Keep in mind about the target group, keep in mind about the user state, what they're doing actually at certain particular time when you want to target or when you want to interact with them. And then you need to know what is their journey. So for example, if we talk about elderly, you also need to think about during an elderly's dinner time, what comes in, their food comes in, and then after that, in a facility, maybe after that, nurses will come and check their vital signs, and of course, then maybe towards supper time, do they provide them with some food or not? So all this will be categorized as a journey for a particular specific type of activity in an elderly care. Because don't only think about, hey, I already installed IoT and my work is done. No, you have to think beyond it. You have to think about their happiness in a particular situation. You have to think about whether, whatever type of devices that you want to monitor, it's actually comfortable for them, or do you want to think about the type of data that you get is actually something that you can do your analytics. So journey is a very, very big thing. So you can break it down. That's why when you see here, you can break down into many, many, many. If you're familiar with Excel sheet, right? Let's try to do it on Excel sheet table. You can see that, you can have many, many thousands or rows. So if you want to analyze it alone, just by using your eyes, it's going to be very tiring. That's why knowing a computer program helps a lot. Sometimes, you can just do it on a Python or whatever computer language, maybe C++, maybe VB.NET, or whatever, you can see that you are familiar with, or you have been taught before, or maybe even Excel programming. You can always look into that. Excel also has some VB built in, and of course, R programming and many others. So again, I talked about channel content. So these are some examples, but there is no successful experiment at times. Therefore, you may have to repeat it to make it successful. Many um, what do you call successful companies, when they launch something, a campaign, you will notice that even Facebook, they will always have updates to their software patches to make sure that things are running smoother. And then that's why they get a lot of survey from people. They look at people's response and keep on improving it. So that's why every experiment is unique to whatever you're trying to do. And a lot of times, it will be updated to make sure that it works uh, better and better. So you guys are all familiar with Waze, right? I'm assuming everybody is using Waze, Google Map to find where you want to move. Either you want to drive your car from one point to another point. So Waze is a very, very good example of big data analytics. And then I will talk a little bit about descriptive analytics, predictive, and also prescriptive. So, of course, in English, descriptive means you describe, right? So for example, right now you are looking at maybe you are owning a company, and then you need to know how much money your company had made, the revenue, and then what are the products it has sold. So then suddenly you will see a dashboard. So dashboard, there are a lot of great softwares out there like Tableau, Power BI, even Excel sheet can do graphical output, right? So you can just look at that, and that dashboard you can present it to your bosses, or if you are the boss yourself, you can look at it and see, hey, within this year to this year, I have made this much of revenue. What is the profit? What is the loss? And then what is the most famous product I have sold? So this is an example. So those are descriptive type of analytics. So when you talk about predictive analytics, it's like, okay, when you put on weights, right? So it will tell you that, okay, from now it will take me 30 minutes to go from Unit 10 to probably KLCC, example. So another day you look at it, it will take you 40 minutes. So how does Waze predict that? So Waze predict it through the many, many input it has got from a lot of cars using it. The more cars using it, the better its prediction. So some of you probably have tried Waze in a kampong area, or tried Waze in an area where there are not many people turning on it. You may realize that it's sometimes the prediction is as good as no prediction at all. So I've tried it in many places. Yeah, you can go out of the city where there's not many Waze users. So even if there is a traffic jam, it might not be able to predict, because at that particular time there's not many crowd providing the input to Waze. So Waze has a system that been collecting the data every day. So if it has been collecting the data every day, it will kind of understand that every Monday morning, there will be traffic jam from maybe Unit 10 or from KLCC to Unit 10. So for example, somebody want to move from, so it will tell you that it will normally take 40 minutes at 8 o'clock. It will tell you that it will take 35 minutes at 9 o'clock, and maybe 30 minutes at 3 p.m. So example, right? So how do Waze knows about that? It's because all the data it has collected regarding the time, people's journey, the traveling journey, and then the different days, and they also collect traffic jam inputs, because they can see that if a car is moving too slow, they can get that information. So this is all predictive analytics. It tells you when you put on Waze how long it takes, right? So those are predictive analytics. It tell you the time. So I also can say that I build a product, for example, and I can tell you tomorrow whether it's going to be rain or likely not no rain. So maybe this is how I learn from the data that I have been collecting all the while. So similarly, we do predictions in many cases. Sometimes you also see people predict stock market, right? Will go up or go down, So these are all prediction, but it's based on big data. So you must have a lot of recent data. You must have the capability to store the data, analyze it, and then automate it so that it does a real-time prediction. So Waze has an automated real-time prediction capability. So another way is prescriptive. So sometimes when you go to doctor will say, okay, you have a fever, I will give you this type of medications, because the doctor will prescribe to you, right? So similarly, in analytics, there is an area called prescriptive analytics. It's also like ways. Not only do you want to tell that you want to go from Uni 10 to KLCC, it also tells you what roads to take. Maybe make a turn here, go via mines, or go via some other, roads to reach KLCC, because or they may even do three or four type of prescriptive analytics to tell you which are the routes you want to take if you want to avoid tolls, or you want to go a bit deeper, like you don't want it to take longer than what is predicting. So these are the cases of analytics that you may hear it, and of course there are some new ones they call maintenance analytics. Many other areas will come in, because they also do different type of analytics. So the three most common one are descriptive, predictive, and prescriptive. So now moving into what do we look at AI, right? So we talk about artificial intelligence. So what is basically all this artificial intelligence? What is machine? Why does the machine learn? So you may hear about all these type of things. So I will tell you in a very simple way. Okay. So from big data analytics, we are very interested to automate, because we don't want to be sitting down and seeing the screens. Just imagine if you are a security company and you are looking at putting cameras in all the banks in Malaysia, and you want to monitor, and you will put let's say 4 or 5 human beings in front of that, and you have thousands of cameras. Sometimes you might not be able to detect all that manually, right? So sometimes you need to automate it. So some automation can occur via cameras, because you detect something, and when something moves out of the normal, the cameras will notify it. Actually, it's not the camera, it's all the system that's connected to the camera, and how the machine learns and from the past, and how it will notify the security or the operation maintenance team to take the necessary action. So here, the purpose that we will be talking today is using your big data that you have collected and you have designed, because you need to know what are the fields that you need to collect. Then once you store it, you learn it, uh, you provide the machine the capability to learn it, and then it automate the task from now on. So that's the main purpose, one of the important purpose that companies are using. So it could sometimes you don't have enough knowledge of how to start. So that's why people will do experimentation before it actually moves out. So that's why you might hear people like data scientists, those kind of terminologies that comes in, right? The data scientists will look at the data and say, okay, this is how we're going to predict. We need this data, and then they will say that, oh, okay, the accuracy that I can come out of it is only 80%. So if the accuracy is 50%, it's just like a toss of a coin, right? Sometimes we toss the coin, you come about the head or the tail. So that's as good as better. Don't predict at all if you get 50%. So if you get like 80, 90, then you're a bit happy that your experiment works quite well. So now I will touch on how does the machine learn basically. So if you have a computer, how do you want to train it to learn? So for example, you need to provide it with enough previous historical data or pattern, some pattern that makes sense. So for example, how do you know when it will rain? So maybe the meteorologists are the people that look at this, and they will see that, oh, there's a pattern. Before it rains, the wind is this type of data that they collect for the wind, and similarly the pressure of the air and all that. And of course, at the same time, they will receive data from the satellite, and they will look at that. So those data must have a pattern. If there is no pattern, everything is random, then you can't predict anything. So that means the data is not useful. So then after you get the data, you need to predict the future outcome, because from that pattern, you are able to predict. But in order to predict, you must be able to do this first before you can feed it to your machine to learn. So for example, you may want to put this into an algorithm, for example, a simple linear regression. You can just write a Python code for simple linear regression, and then you can see, hey, it works very well. The accuracy is also quite good because the data that you have provided, it can predict, a very good simple linear regression. I'm just giving a very simple example, but in fact, it's more than that. In certain cases, it's quite complex. So then you say, okay, I've done it. I'm a data scientist. I've done this work. I'm quite happy. So this model works in a Python. Now I want to automate it. So how do you want to automate that? So you want to have your machine to take that algorithm and now do it, run 24 by 7. Why you want to give it to your machine? Because of course your machine can provide faster computation, and of course the machine can store big data, and of course you can also look at the variety of the sources. So as a human being or a data scientist, a person cannot do so much without the help of a computer to do this type of task. So then once you're done your experiment, you need to look back. Sometimes, the data that you get could be a stream of data from 2 months ago. But now moving forward, after 2 or 3 or 4 months later, would you still want to use that old data? No. So then at the same time, there could be a different problems that coming in. Maybe you realize that it's not only the air pressure or, for to determine whether it could be other things. Maybe at that particular time, it could be, suddenly there is an effect from a neighboring country like volcano erupt or something, that may affect it. I'm not sure. I'm not a meteorologist, but I'm just saying that there could be other variables that are affecting it. So do look back at what you have done as a data scientist. Then, of course, you need to update your machine's automation capability also through that algorithm. So do analyze your performance metric. Maybe today you're getting an accuracy of 90%. Suddenly, if you get an accuracy of 70%, that also triggers you to look back at your data. Is your data being updated, or something else is affecting it? So for example, you are also predicting stock market, but then you realize that, hey, it's not going to what I have predicted earlier. Maybe because there are some other factors that made the market to behave very, very differently. So be careful about those kind of things. That's why you need to keep on analyzing the performance of the metrics. Could be the weather data. If you predict it rains, and every time you predict it rains, but there is no rain, so something is wrong. Then similarly, every time you predict something will go up, but it's not really moving up, it's moving on the opposite direction, that triggers something is not right. So again, how would you do it differently with those historical data? Always keep on thinking it in a different way, and then try to automate as much as possible. So that's why a lot of times, sometimes even though you are a power electrical engineers, it's always important to always pick up fields like learning Python, R, or what, so you can look into automating some of the work, the task. Of course, if you know Java, that's probably even better. You can automate many, many other tasks and then let those machines to do their task without even looking at it. So in many companies, they repeat this process until they find something is great and there is a growth that they are looking at, then it runs on its own. So you can see that Facebook's page is running on its own. Of course, there are optimization happening at the back and the process there. But again, you can see a lot of things are being automated. So now let's see an example of a website. So when you see a website, I think a lot of you have gone to Lazada, Shopee, there are many, many others, right? But sometimes some people, they go there, they will just look at it and not buy anything. So it's always good for this type of companies, they need to analyze. They call it the web part analysis, that how many people actually go to this introductory page, how many people that go to the shopping cart, how many people that actually pay, check out. So of course they are very interested on people paying, right? Because the amount that you can see the funnel here, right, towards the end, it becomes smaller and smaller. The earlier ones will have a thicker lines because there are a lot of people browsing. So maybe 100 people are browsing, but only maybe 10 are buying for that particular product. So you need to analyze. But sometimes if you see that a lot of people are just viewing, but nothing is happening on the selling part for a company, so that's also not good. So that's why they have this kind of visualization. There are many type of visualization that helps you in your descriptive analytics. Descriptive analytics mean describing, like I mentioned earlier. So this is one example of description for people who are analyzing their web traffic, whether that particular page is pretty successful, or every time a person goes to that page, they bounce off, they go to another page, or they leave that particular company's. So it means that something is not good there. You need to put something interesting. So that's why you can see Shopee, Lazada, many others. They're putting various kinds of great promotion to keep on people to keep people coming back again and again. Sometimes they will give you vouchers, coupons, and many other deals, right? So those are example of how they analyze it, and after they analyze, they do a decision real quickly. So they work very closely with their team. So another way, of course, is also social network analytics. So sometimes people use Twitters, and even in Twitters, a lot of time we can see feedback. Some people say, "Hey, I'm not happy with this product." Some people say, "Hey, I'm very happy." So how do social network analytics help you? So they will gather the feeds from Twitter, they will gather the feed from Facebook, they will see for certain type of products. It could be, in this case, it's Tic Tac. It could be a different type of brand, maybe chocolate or whatever. They can see whether people are talking good or bad about it. So when they know that there are a lot of people complaining about their product, then maybe they might discontinue that particular product or improve that particular product. So these are all called sentiment. You want talking good or bad. So they're trying to put listening tools to capture all of this from tweets, from social media. So it's also good. So if you, let's say, as an engineer, you work in a company, a power company, or like telco, like Celcom, DG, Maxis, they would want to know what people are talking about it. Maybe some people are saying that, hey, the network is not really good in this area. So if suddenly they get a lot of people talking about it, they listen, and then they will say, okay, without even them complaining, giving a call to your call center, they will already have a good idea that, hey, people are already complaining around this area. So this is a proactive way for certain companies to actually use analytics to solve a lot of things. So that's one of the reason why you need to listen to social media, blogs, and the various type of sources, the data sources. So if you look at a small diagram, I did it very small because I don't want to go too deep. So there are a lot of systems that people put in place. There's also Apache NiFi. Some of these are all open source, Spark, Solar. So they use that. They analyze it first. They will see that. Of course, the data scientists, data engineers, they work together. Data engineers work in terms of doing the pipeline, how the data comes in. If it's coming in continuously, we call it streaming. So the data keep on being streamed from either Twitter, Facebook, or blogs, or from whatever sources that you have. Then it will go through your algorithm that you have designed earlier. Could be a very simple algorithm, could be just some regression, or it could be a very complex algorithm that you have designed, and of course you could probably use some of the libraries available outside, and put those things together, and when you have looked at it, you are happy. Then you run it, you automate it on your servers. So when you automate it on your servers, it will give not only a continuous streaming coming in from feedback of Twitter or Facebook, but also you can actually have the graph coming out. Or if nobody is looking at the descriptive data presentation, you can even do alerts that it will alert when it reaches to maybe 100 complaint level at a particular location, send it directly to your operation and maintenance staff. So for example, if there's 100 people complaining around Serdang area or Kajang, town, go and look at it. So then the operation maintenance team will say, oh, okay, these are the type of complaints. I should go and see why it's happening. Maybe your base station or your cell station have a problem around that area. Similarly, it can be used for not only telco, not only power, but many other industries that are out there. So we talk about all of this. It's nice, but how does algorithm or machine learning helps? So I give you a very simple example. So this example is about if somebody goes to a movie producer and say, "Hey, I have this very good story to tell. Can you actually sponsor a movie for me?" And then I will take this number of actors and I will need this much of funding for my movie. So sometimes they go to producers, but then if there is one case a year, of course the producers can take their time and can analyze whether this movie is going to be a critical success or a failure, or either maybe just break even. So what they do is, so in this particular case, they analyze two fields: the type, whether there's how much A-list celebrities, what type of budget. So this is very easy example, because you can look at whether you have A-list celebrities, the great celebrities are there, the actors and actresses, or whether what type of budget you put in. So very simple. You can draw a tree by yourself. No need to use machine learning algorithm like Python or in R, because you can draw this yourself. So you can see on the right hand side, you have somebody coming in and propose that I want to do a movie. Can you fund for me? A fund means give money to them and run and produce the movie. So looking at it, you can easily see that in the past, when somebody had given this type of proposal with more A-list celebrities and with the estimated budget high, so you can see that the triangles, the white color triangle on the upper hand, you can see it creates a mainstream hit. So you can easily divide it into three segments, right? Because there are only two variables. So then you can come up with a tree and say, okay, most likely if you have a higher estimated budget and a lot of good celebrities, definitely it will be a mainstream hit. If you have less great celebrities or your budget is small, it could be also a bust, probably a failure. So then you already have the data from the past. Then you can predict that if somebody comes for your proposal today, this will be the outcome. Easily done, right? No machine required. But just imagine, this is a simple case, just for your example. But what if you have a lot of data that you want to collect, like which country is this picture being shown? What is the release date? Sometimes there are certain dates that even you have good actors, but those dates are maybe some like maybe during festive season or what, the outcome will be different. And also, of course, probably different country will have a different outcome. So then if you want to go very detailed, you cannot be just drawing a chart like this, right? So that's where you need the help of algorithm. You need like Python or R, and you just have a basic tree algorithm that will help you solve a variable of more than three. Like for example, here you have two variables, A-list and estimated. Then there you can probably have 10 or 20. So that's where you need your machine to help it. So this is why I would like to emphasize that at the end of the day, you want to do an algorithm, take the data, and then your machine, which is the algorithm, will learn from the data that you provide. So this is all about machine learning. So you will not only have three types of algorithm. You can have various different names, regression, and then now you hear things like deep neural network, CNN for CNN for image type of analytics. So there are many others. Do spend your time a bit on looking at what are the available algorithms, and some of them they have libraries. It's very easy to write it in Python, 2-3 lines of code to just call upon that algorithm, because those algorithms have already been stored in the library, so you can reuse that again, but you change the variables and input the data that you want. So you need to spend a lot of time on your data. So that's why data is very important nowadays. So another example is understanding social network relationship. So in the past, there's a karate club, and within the karate club, you have the central people. Let's say, for example, number one and number 33, 34. So they will say, oh, looks like these people that are in the middle are the influencer of the club. Why don't we go and meet them? We share some information with them, and they will share the information to the rest of the people. So even in your universities or in your class, there are some people who are probably in the center that are big influencers. So this can be used in many situations. For example, when you are dealing with social media dissemination of information and so on. I won't cover so much of this, but I just want to give you an idea how this works. So even in Facebook, you can see that how each of these connections are. They are people that just do a lot of one-way connection. You can see the way it's being portrayed and through graphical interaction. And then a lot of people with a lot of friends, you can see that their representation is very different. So when you understand that, and when you have something that you want to share, you know that your information will be shared in a much efficient way if you target the type of graphical representation in whatever intention that you want to target your message, or you want to target your advertisement, or you want to market, right? So if you want to market to people who do a lot of one-way communication, it might not be effective. So similarly, here there's an example of if you look at on your right hand side, there were 1, 2, 3, 4 orange colors, and those are the influences of one of the Japanese graphic novel spreading. That's a pretty good example how that novel was being spread through these four people. So it's also good to understand graphical analysis that you may come across later on. So now come back to what I do in a telco environment. Uh, I have about 30 minutes, so I will try to be a bit faster now because we are moving into quite an interesting subject. The earlier one was just to get you an idea basically about how machine is and why do you need machines. To do your prediction. So now when you look at a mobile company, a lot of time mobile company collects data for maintaining your stations. You need to have a good coverage. You also need to be able to call from one place to another place. And then, but on top of it, sometimes you do give information about, your age, gender. And then, of course, telco really likes to also, track about your interests, your likes, your dislikes. So again, when you have so much of all this information available in telecommunication, and in many companies, you have quite a number of information available. So what does it do? So a lot of time you know that you can use your handphone to pay. It's also your wallet. You can use your handphone now for My Sejahtera and many other things, right? So basically now your handphone is your Internet of Thing, right? It's basically, you don't need to have a camera for Internet of Thing. You don't need to have a sensor on you. So when you have your mobile phone, it's actually an Internet of Thing. So at the same time, your mobile generates a lot and lots of data. So if a telco company has so many millions of subscriber transacting at numerous location, making calls, looking at WhatsApp, and then looking at websites, doing Facebook interaction. So you will just imagine how many billions or trillions of transaction can happen. So this is actually big data. So you can imagine how rich the information is. location data, call quality, network information, and similarly, with whatever industries that you work with, there are a lot of sensors. So, example, if you have heard about airlines, right? Just imagine on the flight how many sensors they have and how many billions transaction would the airlines be looking at, or the maintenance of those airline crews will be looking at. So just imagine. So, what does the information do? Of course, a lot of times we have to be careful. A lot of companies do not use your information just for the sake of using it, because there is all the rules, the governance. There's also privacy. You must have heard about PDPA, Personal Data Protection Act. You probably have heard about GDPR, and even Facebook can't just simply use your information anyway. So a lot of times you see that you have to sign a form, and it says that your data will only be used by the maintenance people or the company itself and will not be given to somebody else, right? So those are some of the areas that you need to know. So similarly, when you design the elderly healthcare, the data or the health related information, their medication, and of course in hospital, the hospital records, this are all top secret. It cannot be shared, it cannot be leaked. If it's leaked, then you could actually face big legal consequences. So, but there are sometimes governmental bodies. They are, sometimes collaboration between companies that they might want to use certain data. And of course, if the customers sometimes have also signed, you may see that in certain cases where you go to your mobile apps and say, I allow this data to be used for research purposes, or I allow this data to be used for something else, then maybe those companies would be able to use some of the data. But again, you may also notice that sometimes when you go to a lobby of a building, there is cameras. So then you may ask, should the camera actually record your movement? In terms of privacy, probably no. But in terms of security, of course, then there's a different way that they can say that it's a must from security perspective. So again, security versus privacy. So you can see that a lot of places they will have cameras and then see if something is happening out of the norm. Again, why do we need data? So right now, a telecommunication company only knows about telecommunication data, doesn't know about many other things outside. So similarly, government maybe know about governmental data, but doesn't know a lot of things on the other side. So that's why there should be some collaboration, should be a healthy partnership among companies, and this is how we can improve our country. So for example, if you can analyze the origin and destination data of drivers, you would know where they start, where they go to. Then you can definitely design your smart cities and also smart roadways, right? You will know what time they start. Then you would probably need to also work with Waze, depending on whether Waze wants to release those information or not. And then at the same time, you also want to work with city planners. You need to know where the events are, the crowds are, and what time of the day. You need to also do some forecasting of people movement, analyze the population. So sometimes certain buildings have this information that so for example, you may go to KLCC, you will know what time of the day there are more people. I'm talking about prior to MCO. Now, of course, we won't be able to measure that. So if you have those information, then, in terms of building a city, you can work with different other companies like transportation, government, and maybe conduct surveys. So sometimes you may not even have data, right? Then what you do, you ask people to go out and carry on surveys, can be consultants, or I talked about social media analysis, right? Like Facebook, Twitters. You can also start your listeners. There are some softwares that you can use it to actually listen, but again, it's very limited because they don't allow you to get a lot of this feedback from Twitter and Facebook unless you pay for their premium services. But if you want to use the free one, you can get certain levels. So again, what my slide here says that um, no man is an island, right? So you need to always collaborate with each other, with the different organization, and so that your data can be 360. Okay. So even in telco company, you can see that we have telco data, right? But then we also need to use algorithms. So now, for example, the algorithm on the right hand side is time series. I need to know that which time of the day my cell station at this particular area is congested, at night, during the day, or what. So again, we did an experiment. Of course, Google will tell you when you have Google Maps or Waze will tell you when you want to move from point A to point B. So we did an experiment. For example, one of my colleagues started from Jalan Duta Toll all the way to KLIA. How long does it take? So with this, we were trying to target a certain persona. Persona is a target audience that we want to look at. Maybe just any drivers that are actually driving around this particular path. And during a particular time, let's say 12 to 1 p.m. on Monday. So how do we keep track? Because we have a cell station. We know that when you have a cell station, it will hand over the signal to another cell station every time the person is moving, right? So from that, it is our measurement. We don't need to turn on the GPS. We don't need to use Waze or Google Maps. So in a way, telco can actually do this experiment if they want to. So this was an experiment conducted quite some time ago around that area, Jalan Duta Toll to KLIA Toll. You can see origin and destination. There were 260 cell sites and collected about 35 million events over 5 days. So we wanted to collect data, right? And then and of course, within that time limit, we wanted to see how people are moving from this particular location to KLIA, only that particular area that we are interested to study. So within that, we are able to tell that a journey will take about 37 minutes or 43 minutes. This is according to the counts that we do that take from that particular KLIA toll to Jalan. And then we can validate it with Google Maps, or we can also use Waze if that takes that much. So this is how we tried want to show you one experiment that we can do from the telco perspective. So this is quite close because when you use Google Map, it's about 34 minutes. So it's quite close. Maybe because we don't have that much of um, crowd that Google and Waze has. So when you have, like I said, when you have bigger data, then you can do the averaging well. So when you have not that many, you can still do it, but maybe it may not be as great as Google Maps and Waze, because Waze has millions of users and how many type of collections they are collecting. So example here, and then in Los Angeles Department of Transport. So how they're using AI? Example of smart city. So when you look at the Los Angeles Department of Transport, they're using it on real-time monitoring, and then of course they don't only look at the screens, but they also look at automatic adjustment of some of the signal timing. Maybe if they realize it's a certain part of the day, automatically the timer, it will allow you more green light or red light or whatever not. So you can see that they have 4,600 traffic light around that area that they are using it for this automated use case. So these are all artificial intelligence in the play. And then they had reduced the traveling time by 12%, and also the traveling speed went up by 16%. So this is a centralized traffic control center. Of course, they have it that too, because sometimes you also need to monitor. You cannot have your AI running autonomously without people monitoring it. You have heard about autonomous cars having collision, right? So there's no 100% accuracy on those kind of. So that's why you need to have people actually to look at it, maybe collect the data, understand the data, and then or even audit or monitor in certain cases. So these are real-time monitoring, and they also do automated adjustment. So some cases maybe they don't allow automated adjustment if the algorithm is not working properly. That's why experimentation is very, very important. Roles like data science and data engineers to bring the data in, it's also very, very important. So this was the use case. So going back to the Celcom use case, we not only use it for that particular experiment that was just to show you, but the purpose of us having a data in like Celcom in other telco in Bangladesh called Robi Dialog is to detect bad cell site, how it impact customer, are there any call drops, what are the call failures, even now you look at your broadband and what are the quality that we want to monitor. So those are the fields that actually we are looking at. But again, what I'm saying that you can still do an experiment with this information, because you know the location information and a lot of other things that tell you a bit on what the problems are being faced. So with those kind of data, you can actually do location analytics. So location analytics means you can look at how to build smart city. You can also work with the government and tell which route is being impacted the most, where people are moving actually from 3 a.m. to 11 a.m. on certain time of the year. And then when you know, then you can actually build better roads or put more people at certain location. So in this way, everything is very structured. You don't randomly use your resources at certain facility where you don't need it. And in this case, you can actually plan your trips. So you can see from experiments, um, show it on a map, which is descriptive. Then if you want to move forward, you can use AI and do more things out of it. So then sometimes you may wonder, right? How can we make it much better? So yeah, why don't you start looking at ways? So when you look at ways, sometimes ways don't give you the data, but there are other ways. If you are a software developer, you can actually scrape that information from ways, but of course you can't scrape it from too long. You can actually see certain information being taken out. So we have worked with this with one government agency, and we have tried to actually scrape a Waze site to get certain information. So for example, we were using Waze data for Kuala Lumpur traffic analysis for KL. And then here you can see that we can see the accidents where it happened, hazards and jams. You can't get it from your mobile app because your mobile app is designed for your own use, but actually you can still get the data from the internet, and Waze do provide it. I think you can go to a www.waze.com if I'm not sure, and there's a way that you can grab this out of Waze. So again, the same example. Okay, so when you have waste data, you have your own sensors. So if, for example, you are a building owner and you want to know how many people are going in your building, they have taken the elevators, and of course, if they are signed up through Waze, and you also have a collaboration through Waze, you would know that okay, somebody have stopped in this building and then they have gone from one floor to another. Waze wouldn't know which floor that people are going to, but that company will know because they would have installed Wi-Fi, and each Wi-Fi and each flow will tell where the person is. So if like there is a collaboration and there is a account with Waze, you can always have this greater way of analyzing the movement. And if that's being allowed by the Waze user, again, like I said, right, you have to be very careful about Personal Data Protection Act. uh, you can't just simply go and ask data from the other side, and nobody will want to give you data because everybody are very, very careful on this PDP Act. So you also have gone on a website, probably just visiting, buying like Shopee, Lazada, and many others. So those companies will track this kind of data, that they will know which people come from which country. So these are all descriptive analytics we talk about, like example on dashboard, right? So how does it help? So it will help to say that how many people actually came and visit, where they're coming from, and then what are they're doing on your website. So these are information that's important. and then what countries are coming, and which countries are actually buying. And if you look at, there are some countries coming and they're not doing anything, maybe you may want not to sell anything in those particular countries. So another example is, this is, for example, we are doing real-time analytics. We are seeing a seasonal pattern of what people are doing, the number of people connecting to our mobile site. So maybe this mobile site is in a KL Central area. So here you can see a very good seasonal trend. You can see up, down, up, down, up, down, repeated every day, like April 10, April 11, 12, 13, 14. So these are all patterns. So you can see, oh, okay, certain time of the day, there is more people doing calls. So then you can think that what you should do with this particular site, right? So if there are peaks, do you want to invest more and putting more cell capabilities inside there to support these people? Maybe you may say no, because this only happen at certain time of the day, and you can make away with it. So this is all comes back to the return of investment. With having this analytics, it's always good to know. So then that's a line you can put on a threshold that you don't want people to cross that line. So of course, if you have an AI system, it's good. It will monitor it and it will inform that this line has been breached. And what do you do if the line has been breached? Maybe you want to configure now your neighboring cell to take over at that particular time when this line has been reached. So how AI can help mitigate risk? This is something that I have, I've quoted some time ago, and basically it's available in one of those white paper. So basically somebody asked me about, can you use AI to mitigate risk? Of course, if you use it, it's better in a real time. So sometimes company, they realize that, oh, they have made a loss because they only got the report on a monthly basis or quarterly or yearly, right? So you didn't realize that you should have taken action at that same time when something happened. You should have automated it, and the risk came, notification happened, and you can send your personnel to actually go and look at it and solve it immediately. So like I said, one simple way is to detect anomaly. It's like you see a wave going on April 8, 9, 10, 11, 12. Suddenly on April 14 and 15, you can see a spike, right? So what do you do on that spike? So in the olden days, we use a rule base. When they spike more than 550, we do something. But nowadays, if you use rule base, we realize that there can be also problem, that not only the spike happen, but it could also be a problem where something is not happening at the lower end. We call it sleeping cell. The cell, nobody is going there, but something is bad. So rule based helps you to detect threshold or certain barriers when it's being reached, but there could be a minimum case that you might not be experiencing, or there could be a middle level that it's showing a pattern and you have detected that that pattern is not good. So that's where you need to keep machine learning to help you and tell that, hey, this pattern has been repeated. So then you don't even look at rule, but you can use this. Sometimes you may ask me, can you use rule based and AI together? Yes, of course you can do that. That's also another way, but again, you have to be very careful. When you have too many rules, then your system will get confused and not know what are the precedents to take. So be very careful of that. Um, so again, I think a lot of you have gone to the doctors before, and or how to calculate your BMI, right? There's a formula about your height and your weight. But if you want to use machine learning, you can actually do it. Sometimes you can use cluster. You probably heard about cluster. You can use a DB scan algorithm, or you can use isolation forest. So in a way, when it isolate for you and tell that these are the certain number of people that you will characterize as not normal, anomaly, which is group 0 and group 3, which is underweight and obese. So you may not really need to use formula. So I'm just trying to share with you experimentation. It's the way to find out that you can derive a formula out of it, or you can use artificial intelligence to help you derive. But you may still see that there are outside areas that it may not fully covered. So again, it's still similar. If you use a formula, sometimes the BMI may not give a correct fully description. Sometimes a person with a BMI high, but the person is quite big or muscular or have a very heavy bone, doesn't mean that the person is obese. So again, formulas help us to a certain extent, but don't forget that AI also could be used. So I'm just sharing with you that you can also use algorithms there. So now let's go back on the elderly case use case. Um, so now what do you want to monitor for elderly case? So for example, if you want to build a facility for them, right? So you want to monitor whether, there are elderly cases where fall downs occurred. You want to monitor whether osteoporosis have happened. What are their food intake? Are they having depression, or are they having dementia or memory issues? Or you want to know where the persons are moving, especially the real time. So then sometimes you may list it down what you want to monitor. But then I've taken this reference. It says that, okay, these are the things that it's great to monitor: headbands, camera clips. But again, remember I told you guys about, we must always think about the comfort of the patient. You must always think about the cost that you are going to put in. You must always think about the budget that you want to do the project. So those are all important things that must come when doing an engineering design. So in this particular example that I've taken, you may want to think, what are the other IoT on premises monitoring would you require? So don't you think there are other things that are missing from here? So there's something that you could probably think about. This is not the only thing that you may want to put in your elderly care center. There are many, many other things that could be useful. So another thing is, I've taken one of this example. It says that, let's say there is a health system, right, that you are planning to integrate. You can't just build a standalone elderly care facility without connecting it to other ecosystems. So for example, that, let's say, it could be a hospital, elderly care with a connection to another hospital. If something happens that the patient is not feeling well, you may want to connect them to a nearby hospital. So then after that, hospital will prescribe medicine. You may want to connect that through ordering of their medicines through pharmacies, right? And at the same time, you might want to think about other things that could be connected. So I want you guys to think about this an example. Should you connect to other cloud health services? Some services could be connected through the normal application programming interface. They could be having a service located at the hospital itself. But sometimes, we talk about cloud. What is cloud? Cloud is like, you heard about Amazon Cloud, Google Cloud. So should we connect to, for example, there is a very famous, like a Wikipedia for health, and it's available in US. Should, your health facility connect to them for advisors? Because sometimes the patient might want to get second opinion and they would want to use this. And if you give them a pad, do you want them to also check? Because you may have a doctor in your facility, but they might want to do something through this. Or do you want them to just use a normal internet to browse? So again, you want them to have a premier facility. You want them to have a normal internet facility, or you want to actually think about, your doctors providing everything end to end, or how do you want to do it? So do think about all this other value added. So don't just think about, having a healthcare there and then that's it, and then turn the power on and your work is done. No, you have to also think about um, what are they going to use the services for. But again, limit yourself, because in every project what you do, there is always a timeline to finish the project, timeline to plan, timeline to deliver it. And so I guess you guys got an assignment, so try not to overload yourself with too many things, and try not to also be too little on providing certain things. I guess your supervisors have explained certain guidelines, but in a real world, I just want to share with you that you need to consider other things. Try to look far ahead. sometimes it's good that you give whatever is required by your company, or the requirements given by your customer or your client. But sometimes if you provide them with something extra, your customer will always remember you, and they will keep calling you. And always do your design from your heart. Think that you are part of that persona group that you are trying to help. So now in this case, the persona group is the elderly care. Try to put yourself in their shoes also. What do they need? They may need other things also, right? So probably just think what is missing from this example. Okay, another example. Uh, if you look at it, they talk a lot about falling, climbing, running, walking, and then they're putting body temperature, heart rate. So yeah, it's always good. We need to have those vital signs. But then sometimes you can't tell whether a certain person is falling. Then do you need to install camera in the facilities of elderly home? This is a question that I would like to ask you guys. Again, don't forget I talked about the privacy violation. Will this privacy violation be regulated in this particular case, or will it be because you need to monitor them, and would you need to get their permission? Think about that. It's always good as an engineers to know all these regulations behind. Sometimes it's not only important for us to do a technical design. We need to know what we can actually do and what we cannot. So how will your design do an alert system when somebody falls? So for example, I have a colleague who have designed a system that identifies falling, or identifies sudden movement. So sudden movement can be that, if it happens within a couple of seconds, that means it's either a fall or either a slip, or something, right? So then the camera had detected that. It's sent to a notification system. Of course, it goes through your AI system is the one that orchestrate everything, and then it will send a notification to probably the doctor and nurses to go and check that room or something like that. And of course, there are other wearables that you can also, of course, install, that will sense from the heart, and it can tell you also if something had happened. So yeah, try to think about all of this, and then try to think how will AI or other means of technology to also keep track of the activities. So it's, but make sure that it's comfortable for the patient, because you cannot give them a lot of overloading of too much sensors, right? So we have to be practical. If somebody puts a lot of sensors on us, we will not be comfortable. So elderly, when you reach certain age, again, it's not also advisable to put too many sensors. So what goes on at the back of the system? So I've given you one of this example, but I want you guys to think. Okay, if you want to architect or plan something, take this example, but architect based on the business requirement. What does the business requirement want you to do? Those are the most important thing. If you fail that business requirement, even you provide extra capabilities, no point, because this is what the customer, the client, the facility require, right? Or whoever have given you the task. And you need to also think about the cost and budget. Are you designing a system much more expensive than it is? And then you need to think about the time to deliver the project. If it's within a year, then you need to make sure that the people who are going to be doing this project can actually do it within a year, and shouldn't take 1.5 years, right? And do put innovative design thinking. Think about the journey I talked about. If somebody is walking, and then something happens and fall down, what do you need to do? Think about some of those areas. Of course, you can't think too many things out there. Think about the comfort also. Maybe think about the process of maybe for elderly care to meet doctors. Probably everything is determined. Like you can create a appointment system. The nurses help them to create the appointment system where the elderly care will be shown to the doctor's room immediately upon them telling a problem to the nurse, and then they don't have to wait too long to see the doctor, or the doctor automatically comes to the room when the elderly have complained to the nurses or to whoever the custodian in that particular center is, right? So the doctor comes. So there should be a process. So this all process should be thought about in a very careful and efficient manner, and definitely make the experience very enjoyable for both parties, right? So in terms of not only managing the elderly care, but also the patient should be quite happy. Then lastly, think about the best engineering practices, whether you should put it on cloud or whether you should create more servers on the location. But if you create more servers on the location, then they will be very costly. If you have it on cloud, you have to be careful on the personal data moving to the cloud. So things like that. So here I have given a summary of what are this is a literature review that I've taken. So the health focus could be the different type of diseases, or whatever you want to monitor. The IoT technologies are the wearables. Review criteria is ease of use, the cost, and then if you have location, would that be the accuracy of the location? If you have some prediction, do you have the accuracy of the prediction? And then what are the safety features of the IoT technology that you want to bring in? So all of this, try to think about it and try to apply it. So elderly patients' comfort and ease of use, do think about that. So these are some of the bullet points. Cost to implement, you may have a civil, mechanical, electrical room or a server room. What type of sensors, devices, connectivity, or do you want to use cloud, or whatever type? Think about the cost to implement, and don't just follow any example that you get from internet. Try to be creative, try to be innovative, and then you can use some example here and there, but again, at the end of the day, try to be innovative. And if there are no enough data or information available, then in certain case, when you have enough time, do conduct surveys, ask questions, and look at more literature review. And like I said, timeline to deliver your project is very, very important. Do research on the technology that you want to implement, because you need to make sure that the whatever you implement, it can also be scalable in future, and in future it will also be used to connect to many, many other different systems. And it should be easy to operate and maintain the system. Make sure that whatever technology you bring in, and don't forget to schedule backup and provide contingency plan. If let's say you have power failure or you have internet failure, do you have a backup line? Do you have a genset generator and all that in place? If that's really required, because it depends on the business requirement. If you must have a 24/7 no power failure at all, then you should think about a backup. Make sure your design is scalable for future technology integration. Make sure you look into security and privacy and regulations. Make sure do not breach any of that. Even though analytics is very interesting, having IoT devices is very interesting, but make sure you don't breach or you don't touch on those things that you're not supposed to do. And resources and expertise to implement and maintain, if it's cloud, or do you want to engage contractors to do it? If you don't have, your company does not do this implementation, then you may want to also think about what are resources that you want to bring in, and then try to automate as much as possible using AI and analytics. So just to give you a brief idea on a big data system, this is something that I've written a paper, and it's in a Springer book. So in a big data system, do think about storage layer, orchestration, how it wants to do the orchestration. You may have a processing component, analytics component, a middleware, and finally presentation layer. But at that time, we were using a lot of our in-house products. So like now, presentation layer, you can use Tableau, Power BI, and many others. So storage, there could be Hadoop. You could probably have heard about Cloudera and many others. So there are a lot of things that if you want to design a big data system will take into place. But this is just for your information. Doesn't mean that you have to put this in your project, because I know projects are there are certain time restriction. So but if you can have it, it's great. If you don't have a system, it doesn't have to be here. It can be from anywhere. You can take from internet. There's a lot of other new standards that have came in since this that I've shown. And then this is something from Google, how to build a scalable data analytics pipeline. So it talks about when you capture data. So Google has their own services. So from capturing the data, when you process the data through a streamlined pipeline, and when you store the data, then you need to analyze it, then of course use it where you want to use it. So it's interesting to also look at it. So finally, I want to wrap it up. So do be innovative in finding ways to solve any projects or any task given to you, or if in future you work with any companies out there, either in terms of marketing the company's capability or their business, try to think of innovative way to grow. And data analytics should not only rely on your feelings, but it should rely on a lot of sources that you gather. So you can actually use social network listening. You can actually team up with some data scientists. If you are an engineer, you can team up with some software developers to automate certain tasks, because you can't do everything. So you need your colleagues to actually build certain system for you. And then don't forget to identify the target group, the persona, and make sure within those group what you're trying to do, they are happy with even the marketing that you send. Because the moment that you send marketing for everyone, sometimes you will make them frustrated. Just imagine you get so many SMS from one company. At the end of the day, you will probably unsubscribe from that company, right? So these are certain things that a lot of companies need to be careful of. So mobile devices application, they form, of course, the customer's journey map. So I think I've shown to you that machines are being used now to learn the learning capabilities. And again, the keyword is automate them. So once you automate, machine can do the capability to detect. This is what we call artificial intelligence. I also showed you mobile analytics, mobility analytics. That means you may want to know where the customer is moving, the location. Then this is great if you want to keep track of the elderly patient. Maybe they can wear a watch or something that you may want to keep track of where they're moving. So they're connect, or if they're within the building, GPS doesn't work, then maybe they're connected to certain Wi-Fi that you will know they're within certain area. So I also talked to you about telco big data analytics, where we use it for network analysis. We predict the customer churn. Churn means is the customer going to leave the company or not? And we also do it for customer acquisition and retention. So this is some of the use case that we use in telco. So I've talked about descriptive, predictive, and prescriptive analytics. I also talked about social network relationship, how you can look at graph analytics and see who are the highest influencer, looking at the neighboring node. And in terms of exploring the elderly use case, don't forget to look at the cost that it's going to be implemented, the timeline, ease of use, and what is the business requirement and the technical requirement that you have been told by your customer to do. So these are certain things that you have to keep in mind. And we talked about artificial intelligence can mitigate risk. Yes, if you have it running on real-time system, you can even tell that something has happened, and you can tell your personnel to look at it immediately. And don't forget that your data sources that you get must have enough historical data, must have a pattern. If it's random pattern, then there's no point of even machine learning to do anything about it. Because even if a human like yourself cannot detect the pattern, then a machine can't do more than a human, right? A machine is only fast in terms of automating and storing and doing the calculations. So finally, engineers like yourself, myself, and many others need to work together to innovate and promote growth through data science, data engineering, work with software developers, and then you can architect the AI framework with them also through a solution roadmap. Like this year, what are the AI framework you want to bring in? Next year, what they want to bring in? So then it meets the company's mission. And also, don't forget to prioritize your customer first. Customer is very important. Without customer, you will not have a company to work on, right? So customers are very important. So we also talk about the elderly use case. So now I open for question and answer. I know it's very little time that I have. It's already 11. So maybe we can go with a quick question and answer. Thank you very much.
All right,
All
thank
right,
you,
thank you,
Doctor,
Doctor,
for your
for your
very
very
informative
informative
overview
overview
on
on the.
the AI, IoT, and the data science. Also comprehensive examples, I would say. So let's open for some questions. Are you guys having any questions? You can shoot up. Any of you have any questions? You can put your questions at the chat area as well. Okay, there's one question coming out. There's multiple of it. May I know what is the typical cost of implementing the AI system? I think that's a bit far-fetched question, but let's Dr. Kirat to try to answer that. Is
Okay.
that a general typical
Yeah,
cost?
it's quite subjective because the cost depends on how big your requirement is. So if you just say you want to have an elderly care of 10 patients, right, in a nursing home, then of course, do you want to invest that much? Do you want to actually buy expensive servers, or do you want to leverage on Google Cloud, Amazon Cloud, or Microsoft Azure Cloud? So then from there, do you want to use their machine learning, because you may not even have enough operation and maintenance personnel to work on it, right? So it's quite subjective. That's a case by case analysis. So I think through time you would understand that you want to put the cost as minimum as possible. And of course, when you talk to Google, when you talk to AWS, they say use cloud because that's cheap and almost free, right? Because they give you credits and how much you use. But again, you got to be very subjective. Sometimes when you accidentally use certain part of their services, your cost can go up. But you can monitor the cost through their meters, right? They provide you the meters, and so I think if you are not sure, maybe you can use the cloud. But again, be careful if you can bring your data to the cloud. So if there is uh, PII, personal identification data, like the IC, what are the medication prescribed. So just be careful. You have to be either anonymize those data, make sure that they ask, like for example, there's a name and IC and all that. Make sure you blank certain information, or you anonymize it so you can analyze it later. That's another very deep topic that I would like to talk to next time, which I have developed a system to anonymize before we bring to cloud. uh, but again, we can talk about that later. That's another, I think, 1 hour or 2 hour session. Yeah.
Exactly. So when you say anonymize, do you also refer to encryption? Like encrypt it before sending and receive? Yeah.
Yeah. So for example, I will have a phone number zero something something something, right? So
Mm,
that zero something can also be translated to some alphanumeric. So every time when I have this alphanumeric unique identifier, nobody will know that that belongs to me because I have done it before I move to cloud. Only I will have the keys to
yeah.
encrypt, because if I'm the personnel of the elderly care center on the premises, encrypt it, bring it to the cloud. And cloud has a lot of tools. You can use their Python running on their Jupyter notebook, and they charge by certain time that you use it, so it could be cheaper. So yeah, when you anonymize, make sure that you have that unique identifier so you can use the data again and again, because you may have one person doing many many activities, right? You want to keep track of that same person again and again, so it better be unique. And there should be a time to refresh that data, because if, let's say, every 3 months you need to refresh it just for your security purposes, every company needs to have a governance to make sure that you do your housekeeping.
Yeah.
That's how banks and
Data
every
cycle.
other
Yeah.
company also do. Yeah.
There's another related questions on the IC. I think this student would like to know whether it's legally or is it illegal to collect information from a visitor. Let's say they have a visitor, allow visitor to come into the premise of this elderly care complex. So whether it is legal to actually take the data from the IC as a security purpose.
Okay, so that's a very, very good question. Actually, it's also quite, it's a question that you need to think from your perspective. So, for example, if you ask the elderly care, they wouldn't want any data to go out, right?
That's right.
Yeah, so they wouldn't want. So, another way is companies are very smart. They will give you a mobile app, right? And then you can see at the disclaimer at the bottom, right? We can collect certain data. If you want to use this mobile app, we can collect certain data for research purposes. So that means you have given your permission, right?
Yeah.
So that should be balanced. Again, you don't want a lot of things to be uh, uh, exposed. Of course, certain things cannot be exposed at all, like their IC, their private information. But information, like you mentioned, you want to put cameras, or you want to know who come in, who they talk to, right? So again, it's something that I would ask you to read up certain PDPA and some security guidelines, and it's good for you to also know that area because it's quite deep. I can't answer it within 2 minutes, but I will tell you that many companies they work around. So, for example, if you want to use Waze, right, there are certain things that they talk about privacy and all that. So, if you say that you don't agree, then you can't use Waze at all, right? So
Yes.
certain thing, Facebook, recently there was a thing on Facebook came out on TV that the whistleblower said Facebook is actually they can control, they know what who are the children that are going to Facebook. Actually, they can control, and they shouldn't do this because Facebook is profiting, right? So do you think that Facebook will regulate themselves? Of course, Facebook will say, give me more data because they want to do business. It should be the government. It should be a regulatory that says, Facebook, enough is enough. You can get analytics, but to this level. So that's why we need to ensure that the regulators become 2 steps ahead than Facebook, and that's very, very important. So if you are designing this system for elderly care, you would definitely be hungry to get as much of information as you want, right? But there should be a body telling you, maybe it's from the health ministry or from media communicate MCMC or somewhere. I'm not sure who should be the right person, or from government, and say, okay, you want to do this, but these are the things that you can do. You can implement cameras, but you cannot go more than that point. So since I would also tell you that this is a great area to go into next, because AI is not just about designing AI. We also should look at it in terms of measuring the trust of AI. So not to forget, this is another area that you can actually venture into. I love to talk about this, but I know time is very limited. We can do another session on this, and
Sure.
another session on business requirement and technical requirement. I'll just tell you that read it up a bit on regulators, and read up a bit case studies. I will also share with you that some of my colleagues in privacy, they have told me, if let's say you go to telecom office today, right, you can see a camera at the back, right? So the camera will say that a customer has come in. So who actually gave them the permission to put the camera there, right? You can think about it. So definitely it could be the customer who says that, if I enter this premises, I'm already giving a permission for the camera to monitor because it's a security purposes. So maybe you can check it out.
Mhm.
Who gave them the permission to put the camera? Is it you, or is it the security aspect that they can actually put cameras which take precedence over privacy, right? Something for you to think about.
I think one last question at the chat area. If someone would like to learn about machine learning, what are the things that they can start with? Is it software, or is it programming language, or something like
Okay.
that?
Okay, I can tell you that I've known quite a lot of people who end up being data scientists. Sometimes I've recruited people from different industries. If you have a software knowledge, that helps a lot, because you can jump into Python programming real fast. Um, but it doesn't actually solve you from being a very good data scientist. Programming is not enough, because if you are a subject matter expert and actually more on power distribution, and suddenly now we have meters in our house, right? Suddenly you can predict if somebody is running their mining or Bitcoin or something from the spikes that you may see. So it's also the subject matter expert that need to put in. So try to pick up a simple language. Python is very, very simple. You can pick it up in 3 or 4 days. Uh, or if you know R or MATLAB, that's also fine. MATLAB sometimes you use in your experiment, but Python is pretty simple. So with Python, it comes quite a lot of algorithm. That's just library. Sometimes those library you type three lines or 4 lines, and you get your thing running. It's so beautiful, right? So I came from a electrical engineering background, and I didn't like computers. In 1990s, you can see my bachelor's degree. But somehow I couldn't live without computers, because everywhere I go, computers is around me. I just had to pick up. I had to pick up. I learned ASB, VB, you name it, and then of course now I love Python. R is also great. I also love MATLAB, but try to pick up at least one. Take up Python, take up, and then you can go to Coursera or all these tutorials. Sometimes there are courses you can pick it up in 5 days. And there's some free courses. So take it up, get to learn Python with machine learning, and I think that's it. It's very simple actually. Don't make your life tough. It's not that you need to be a good programmer. It's actually you need to be a good analytical thinker. So if you know the subject well, especially like you maybe know power better than anybody else, or you know the healthcare better than anybody else, then you know how to program it. Then you do it to that extent, show a proof of concept, and then you can work with software developer and say, hey, can you help me automate it? Maybe your company will have software developer, your company will have designer to do the interface for you, right? So why be a unicorn if you can concentrate on the analytical thinking, right? So again, it's up to your interest, but I would suggest that pick up a certain easier, learn Python quite fast with machine learning. There are actually books available and courses quite fast. You can pick it up even in LinkedIn Learning, in Coursera, and I think even now government also give free trainings for students, if I'm not mistaken.
Okay, I think that's about. There are actually two more questions, but I think we are running out of time. I think those questions are also a bit more subjective in terms of answer. Perhaps the student should look into these answers themselves. So I guess we can end the session. So let us all thank Dr. Keeratpal for his marvelous talk today. And then I think call it a day. All right.
Thank you all.
Thank
Thank
you,
you all.
everyone.
Yeah, thank
Okay.
you. And good luck in your project.
Thank you.
Thank you. Bye bye.
Thank you, sir.
Thank you.
All right. We have another talk next week from our internal speaker. So